In this video, we're going to be taking a look at doing proofs with factoring, and we are going to specifically be looking at an exponential example. So we are being asked to prove that 2 to the power of 2x plus 3 plus 7 times 2 to the power of x plus 1 plus 3 divided by 2 to the power of 3x plus 1 plus 3 times 2 to the power of 2x is the same thing as 2 to the power of x plus 2 plus 1 divided by 2 to the power of 2x. That's a lot. So when we're working on a question that has exponential functions, so where the x is in the exponent and the base is a number, I do often try to use variable replacement as I find it a little bit easier. So I will mention that. But in taking a look at this expression, if I want to try to pick a side to start my proof, I think the more complicated looking side is the left side. So I'm probably going to start on the left. If you wanted to start on the right, you could do that, but I'm going to start on the left side. So I'm going to begin by just writing left side equals, and then I am going to copy down everything that's on the left side. Okay, so I did mention that when I'm working with exponentials, I would prefer to do some variable replacement. So I would like to be able to take out like 2 to the power of x and let that be some other letters so that I don't have to worry about the exponentials. Now, in order to do that, I do have to do something with some of these powers because they're not just 2 to the x, right? They've got addition in them, they've got multiplication in them. So we have done this before. I am going to try to use my exponent laws in reverse to see if we can break this up. So if I have addition in my exponent, we can work backwards and make it multiplication. If I have subtraction in my exponent, we can work backwards and use division. If I have multiplication in my exponent, I can go backwards and use power of a power. So if I have 2 to the power of 2x plus 3, I do see that I have some addition there. So I said we could work backwards and use that multiplication rule and say this is 2 to the power of 2x and then times 2 to the power of 3. Because if I were to multiply those back together, we would add the exponents and we would get 2x plus 3. On our next one, I'm going to use that same rule. I'm going to say this is 2 to the power of x and 2 to the power of 1. And then I'm going to leave the 3 alone for right now. All right, on the bottom, I have 2 to the power of 3x plus 1. So that's going to be 2 to the power of 3x times 2 to the power of 1. And then here I have 3 times 2 to the 2x. I think for right now I'm just going to leave it. And then we'll talk about, how to deal with that multiplication on our next step. All right, part of the reason why I knew I needed to work on the exponents is that on the other side, the exponents are different, right? They have powers with a base of 2, but they don't all have the same exponent. So this is often a strategy I will try when the exponents are different. Okay, anything that's just a number, I am now going to work out. And then anything that has an exponent that's being multiplied, I'm going to use that rule for power of a power in reverse. So here I've got 2 to the power of 3. That is 8. I'm going to move that in front because it is just a number. And then the 2 to the 2x, I'm going to write as 2 to the x and then squared, right? When you have multiplication in your exponent, you can break that up as 2 powers on the same number. So I did move this number in front just to make this a little easier to work with. Okay, here I've got 7 times 2 to the x times 2 to the 1. 2 to the 1 is just a 2. We'll come back to that. And then the 3 is just waiting patiently. All right, on the bottom I have 2 to the power of 3x. I'm going to write that as 2 to the x to the 3. And then 2 to the 1 is just a 2. I'm going to move that in front. You don't have to, but we'll talk about that in the next step. And then I've got a 3, and the 2 to the power of 2x is 2 to the x, and then squared. We're using that rule where we split up that multiplication. All right, I do now notice I have 2 to the x, 2 to the x, 2 to the x, 2 to the x. So I have something that I could pull out and use variable replacement with. I didn't before because the exponents didn't match, but now I have things where the exponents are all the same. So I'm going to take that out and let that be an a, but there is something I probably would do first, and that's the 7 and the 2 here, right? They're all being multiplied, so 7 times 2 to the power of x times 2. So I can multiply those two numbers together to get 14. So this would be 8 times 2 to the x squared plus 14 times 2 to the x plus 3 over 2 times 2 to the x to the power of 3 plus 3 times 2 to the x squared. Now, truthfully, when I'm doing these questions, once I'm comfortable with them, right, at this step, 2 to the 1 was just 2, and then I would have multiplied it with the 7 to get the 14. Like I would have kind of skipped that step entirely and just gone straight to here. Okay, so I did mention variable replacement. You could do it off to the side. We've got a lot of space here on the page, so I'm just going to go for it inside the proof. So I'm going to let a be 2 to the power of x. So if I do that, I'm going to get 8a squared plus 14a plus 3. And then in the denominator, I'm going to get 2a cubed plus 3a squared. Okay, and then from here, we need to factor. So I probably am going to factor those off to the side individually and then see where we end up. So off to the side, I'm going to go do 8a squared plus 14a plus 3. That has 3 terms. They do not have a common factor. They have a number in front of the squared term, so it's not the shortcut, but I am going to multiply 8 and 3 together to get 24, and then they add to 14. So I'm looking for 2 numbers that multiply to 24 and add to 14. We're going to use decomposition. 1 and 24 does not work. I can make a 25 or a 23 with those. 2 and 12, I could get a 14 if I add 2 and 12 together. So we're going to do, you can't see that part. Sorry about that. We're going to do 8a squared. I think the 2 would go better with the 8. So plus 2a plus 12a plus 3. I'm going to group the first pair. They divide by 2. They have an a. So 8a squared divided by 2a is 4a. And 2a divided by 2a is 1. So I get 4a plus 1. And then second pair, I can divide by 3. 12a divided by 3 is 4a. 3 divided by 3 is 1. I got the same bracket, which I was supposed to. So this is going to be 4a plus 1. And then 2a plus 3. Okay, while I'm over here, I'm going to do the other one. I have 2a cubed plus 3a squared. Looking at those, I have 2 terms. Do they have a common factor? Yes, they both have an a, lowest exponent squared. So 2a cubed divided by a squared is 2a, and then 3a squared divided by a squared is 3. Okay, so I'm going to pop those back into the expression over on the other side. So this is going to become 4a plus 1 times 2a plus 3 divided by a squared times 2a plus 3. Now, at this point, I do see that I have a 2a plus 3 on the top and a 2a plus 3 on the bottom, so I can reduce that. Now, you don't need this step. This is just me showing a little bit more than we need to. I'm going to say the numerator is 4a plus 1 times 2a plus 3. And then on the bottom, we're going to do a squared and 2a plus 3. The 2a plus 3's are going to divide out and become a 1. And then anything times 1 is just itself. So this is going to be 4a plus 1 over a squared. Okay, at this point, there isn't anything else I can do with the a in place. I guess I could go work on the other side and use variable replacement for that as well. But if I want to try to continue on this particular side, at this point I would have to put the 2's to the 2 to the power of x back in. So if I do that, this is going to give me 4 times a, which is 2 to the power of x, plus 1. And then I get a, so that's 2 to the power of x squared. Okay, I am going to remind myself about what's on the other side first. So what's on the other side is a 2 to the power of x plus 2 plus 1 and 2 to the power of 2x on the bottom. So I've got 2 to the power of 2x on the bottom. If I use my exponent laws here, we can multiply those two powers together. So that is 2 to the power of 2x. What I don't have is a match in the numerator. I've got the plus 1, it's just this part here. So I notice on the other one, there's no 4 in front. Now 4 is actually a power of 2. It is 2 to the power of 2. So I think that might help us. So I have 2 to the power of 2 times 2 to the power of x, and then plus 1. And then when we are multiplying two powers together with the same base, I can add those exponents together, and that's going to give me 2 to the power of 2 plus x, or x plus 2. And then plus 1 divided by 2 to the power of 2x, which is what's on the other side. So left side equals right side. Now, as some alternatives here, you could at this point have gone and worked on the other side, done the same thing, and then broken up all the powers and you would end up here. Or you could even have done it with the variable replacement. As long as you can get them to be the same thing at some point in your solution, that's all you need to do. Okay, I will see you in the next video to talk about logs.